Hello everyone, today we're going to be working on absolute value equations. So the real question is, what is absolute value? Equations. So absolute value represents the distance a number is from 0 on a number line. So it is always positive. When solving absolute value equations, we will often end up with two solutions because both a positive and a negative number can have the same distance from 0. So let's go step by step and look at some examples. But before I do that, I will define absolute value. Absolute value is essentially making a number positive. Absolute values will always be positive, so that means that ending number will always be a positive number. The ending number will never be a negative number. And we will see these when we do a few of our examples. So essentially, the key idea is that an absolute value equation can have two answers, even though you have a negative and a positive equation. So you have two different types of equations, but you still end up with two answers. And they both will, in the end, have that same ending value of that positive number. I promise you it will make more sense when we do some equations together. So some steps I like to use when solving absolute value equations is first, isolating the absolute value. And then the second step is writing two equations, the positive equation and the negative equation. You'll have one of each. And then you want to solve both equations, and then you could double check your answers if need be. I highly recommend it, and it just shows more credibility in your assignments. Alright, so example number 1. I have x equals 6. So I'm going to set up my equations, one positive and one negative. So you might ask, how do you set up this negative equation? It's simple. You see that ending value of 6? You're just going to turn that into a negative. That's essentially how you set up your negative equation. The positive will just stay the same. So on my left, I have my positive equation, and on my right, I have my negative equation. For this presentation, the positive equation will always be on the left side, and the negative equation will be on the right side. That's just how my presentation is made. You can do it any which way you want, any order. This is just how I'm going to do it for visual purposes. So I have x equals 6 and x equals negative 6. I don't have much to solve here because I already have both of my values, 6 and negative 6. So my answer would be 6 and negative 6. And when I plug these values into that x spot, I would still have positive 6 because we know when dealing with absolute value, the ending number will always be positive. It will never be a negative. Even though we have a negative x, a negative number taking place of x, we will still end up with a positive value. Example number 2, I have x minus 4 equals 3. So I'm going to set up my positive and my negative equation. X minus 4 equals 3. X minus 4 equals negative 3. Now I'm going to want to isolate that x by itself. To do that, I can add 4 on both sides, regardless if it's a positive equation or a negative equation, because I want that x by itself. So on my positive side, when I do 3 plus 4, I get 7. And on my negative side, when I do negative 3 plus 4, I get 1. So that means my answer would be 7 or 1. And when I plug these values in, I would still get positive 3 at the end, regardless. So that shows that even though I have a negative equation and a positive equation and two different answers, I still can get the same ending value. That x can be interchangeable. So I have example number 3 here. Now I'm going to pause. This example looks a bit more different. This one has a 2 in front. Now usually when we do algebra and we see that 2, we know that's a distributive property. But in this case, it's not. We're actually going to move that 2 to be divided by the ending value, which is 8. So I'm going to do the positive equation first, so this can all make sense. So I have x plus 1 equals 2 over 8. I move that 2 from the front to the back with the 8. So when I do that, I do 2 divided by 8. And when I do that, I get x plus 1 equals 4. Now, I'm going to want to isolate that x once more, so to do that, I'm going to subtract 1 on both sides. So that means for the positive side, my x would be 3. Now, it's the same for the negative. You're just going to have a negative ending value, like we did for the others. So I have x plus 1 equals 2 divided by negative 8. Now when I do that, I'm going to have x plus 1 equals negative 4 because you're dividing that 2, the number in the front, by the ending value, which would be 8 in this case, negative 8. So I'm going to want that x by itself, and to do that, I'm going to subtract 1 on both sides. And when I do that, I get x equals negative 5. So that means x could be 3 or negative 5. And when I plug that in, I still get the same ending value, that positive 8. So no matter if my x value was a negative or positive, it would still fit in the equation, and in the ending, we would have that absolute value, which is always, always, always a positive. All right, so some key takeaways is that absolute value is the distance from 0 on a number line. So in the end, that essentially just means you're going to have a positive number. And another takeaway is when solving absolute value equations, you usually end up with 2 answers. So in our examples, we did end up with 2 answers. And when we plug those 2 answers to the equations, we still got that same positive numerical value, which would be our absolute value. So to wrap up, absolute value equations are equations that involve distance from 0, which means they can have 2 solutions. To solve them, we can set up 2 separate equations and solve each one. So thanks for watching, keep practicing, and you'll get more comfortable with these in no time. See you next time. Ari the Math Tutor, signing out.